Alrighty, hello period. I've made this video for you guys to watch because I feel like no oral explanation here. It's going to be a little hard to figure out what I expect you guys to do today. On the whiteboard, after this video, the sub will pull up and you'll be able to see the same work left on the whiteboard, so it won't go away. And I'll try to post this video on my blog as well. But thank you guys after this video and after talking about it and being problem solvers, you'll be able to figure the 3 problems that I'm going to ask you to do today. So in any case, the goal today is to figure out sine over 3 where the answer will be. Okay? So you're here to find in the same set 2 over 3 ends. So essentially it has to be either coterminal or equivalent. Now my for the angles is that out of these 4, 2 of the 4 have to be in radians, 2 of the 4 have to be in degrees, 2 of the 4 have to be positive, and 2 out of the 4 have to be negative. For the fun of it, or just as an example, I'm going to come up with even more angles, just kind of show you that there are infinite angles that you can come up with. But today in class, you'll only need to come up with 3 additional angles. So first, coterminal with 2 pi over 3, we need, let me shut down these, I think that's it. We need to draw a picture of where 2 pi over 3 ends. Okay? So all of these will end here. Now, so the nice thing is, the fact that it's already in radians tells me that I'm going through 2/3 of pi. So there's pi. If I break it into 3 slices, I'm going to continue breaking up the whole circle. So going to 2 of the slices, if I start here and I travel around, I would end right here if I was in radians, because radians are in the here. If I was talking about degrees, it would be an angle that opens up here and rotates this side. So now let's just find a positive angle, for example. So in this case, I know that each one of these slices is 6 degrees, because 180 divided by 3 is 60. So therefore, from here to here would be 20 degrees. That angle would be coterminal with 2 pi over 3. A negative angle would be to travel from here in this direction. So I'd be going through 4 slices. 4 times 60 is negative 240 degrees. Would start here and end here. So to come up with more radian measures, I could just count by thirds. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3 is all the way around. 7/3, 8 pi over 3 would be a positive radian measure. A negative radian measure would be going through 4/3, so negative 4 pi over 3. If I wanted to go around again, I'd go through another 6, so I could just subtract another 6. Okay. So another way to do that, I love the picture and I want you guys to draw the picture. But with the radians here, you'll notice, I'm going to circle these. My angle, actual rotation is adding 2 pi, which in this case, since it's broken into thirds, that's 6 of them. So if I took 2 pi over 3 and added a full rotation, bam, that lands me at 8 pi over 3. And I could add another 6 pi over 3 and get another positive angle. Or I could travel 2 pi over 3, and then I could go backwards 2 pi, so I could go all the way around in this direction until I get back there. So it gives me negative 4 pi over 3, which is an answer that we got. And I could keep going backwards another 6 pi and get to 10 pi. So in any case, out of the angles that you have, again, you're only going to have a total of 4. 2 have to be positive, 2 have to be negative. So I would have to go back, like I came up with these. I have 3 of them are positive, so I'd have to go and erase this radian measure. This condition is I just wanted you guys to be comfortable with both negative angles, so starting here and traveling this direction, and positive angles. Also feeling comfortable with radians and degrees. And you're also find sine of all these angles. The fortunate thing is all the angles end right here. Their terminal side is here. So remember, with sine, the sine is a ratio of the opposite to the hypotenuse. So that tells me, oh, I have to draw a triangle. Remember, when you draw triangles, you always, and then you drop down to your x-axis, or up. If you had a terminal side in quadrant 3, you'd have to draw your triangle up. So there's the triangle that I have here. So I'm going to go ahead and draw that triangle outside of this picture. Oriented, or out the circle, oriented the exact same way. So in this case, since this is my terminal side, my reference angle is always between my terminal side and my x-axis. So I know that this is 60 degrees. So this is a 30, 60, 90. This is my reference angle. So in the 30, 60, 90, this is x, but since I'm in quadrant 2, I have to go left. By quadrant 2, x is negative and y is positive, so this is negative x. This side would be positive x root 3. This side is 2x. I'm also fine with you guys drawing it in your picture. Sometimes they just get crowded. Okay? And I like to sometimes shade my triangle. So in any case, I want my opposite over my hypotenuse. Zoom in here. I'm trying to figure out the sine of all these angles. So the side that's opposite of my reference angle is x root 3. My hypotenuse is 2x. So I have all of these angles will be opposite over hypotenuse, which that reduces, the x's cancel out because x over x is just 1. So I get my final answer, square root of 3 over 2. Okay. We actually didn't end up needing this because it was the adjacent side. So for the first example that you got, I'm not going to do it for you, but it starts out as cosine of a negative 150 degrees. Your first job is to draw a picture of this angle, quadrant 2, okay? Remember, you're going the negative direction, and then to come up with 3 cosine terminal with this same angle. And again, 2 of these 4 need to be in degrees, 2 of the 4 need to be in radians, 2 of the 4 need to be negative, and 2 of the 4 need to be positive. And I want you guys to do the exact same thing that I did. So you're going to draw a circle. From your circle, you'll draw a triangle in one of the quadrants. You'll take the 2 sides that you need. In this case, cosine is your adjacent over your hypotenuse. Okay, so be careful with that. And then in the end, this is not the whole goal of the whole thing, is to actually find out what is cosine of all these angles. Just like up here, we found the sine of all of these angles, was root 3 or 2. So good luck. The 3 problems are on the board. Please write down this example in your notes. It's going to be on the board. You can write it down already. And do your best working together. I believe you guys can be successful with this if you work together and help each other out. I will see you guys tomorrow.